Today we're going to be discussing functions. So, first the definition of a function. A function f from a set x to a set y is a rule that associates to each member of x that's in the set x exactly one member y which is in the set y. The function is denoted by y equals f of x, which is something you should recognise, or what we will call it from now on, the function f such that x maps to y. So that's the definition of a function. The image of a function, y equals f of x, is a set of all possible values that it can attain. So, definition can be written as f of x, which is your image, equals the set f of x, so the range, such that x is in the element in the set x. Now remember, in this case, x is the domain. So you put in all the values of x that are in your domain, and any values that you get out are in your image set. So the composition or composite function of two functions, so your two functions are g and f, is the function h of x. So now h of x is defined as g of f of x. So now a function is injective. So this is your function, f such that x is mapped to y, is injective, or we can call it one-to-one, if f of x1 is not f of x2 for all. So this is another notation piece that you need to know, means for all. It's an upside down A. For all x1 and x2 in your set x, but x1 is not x2. Our function is surjective if your function is onto. So that would mean f of x equals your set y. In other words, for any value y, there exists at least one x such that y equals f of x. A function is bijective if it is both injective and surjective. So then, instead of at least one x value, you change the definition to at exactly one x value. So exactly one x value is mapped to by a y value. So it is unique. So for a function f that maps x to y, the function f minus 1 maps y to x. So this is the inverse function.